Welcome to Network Professionals. Hello everyone, welcome back to our channel Network Professionals. I'm Engineer Javiria Oftab, Cisco certified instructor and member of Tech Awareness. In this lecture we will discuss chapter number 6, Applied Networking. In this chapter, we will explore the fundamental concepts and practical skills required to connect devices to both wired and wireless networks, as well as how to effectively troubleshoot network-related issues. We will cover the following key topics. 6.1 Device to network connection. How to configure devices for both wired and wireless networks. Understanding MAC and IP addressing in computer networks. Configuring a network interface card, NIC, for both wired and wireless connections. Setting up wireless networking in a small LAN environment. How to configure firewall settings for network security. Introduction to configuring IoT, Internet of Things, devices. 6.2 Network troubleshooting. Identifying and resolving common network problems and their solutions. A step-by-step explanation of the 6 stages in the network troubleshooting process. How to troubleshoot both basic and advanced network issues. By the end of this chapter, you will gain hands-on knowledge and confidence in connecting and securing devices on a network, as well as solving technical issues that may arise in network environments. This is our first topic, where we will learn about how devices connect to wired and wireless networks, and how to configure them properly. Network addressing. Network addressing is the method used to identify devices on a network so that they can communicate with each other. Just like every house has a unique address, every device on a network must also have a unique address so data can be sent and received correctly. There are 2 main types of network addresses used in computer networking: MAC address, Media Access Control Address. A MAC address is a unique physical address assigned to the network interface card of a device by the manufacturer. It operates at the data link layer, layer 2, of the OSI model. It is a permanent address and usually looks like this: 001A, 2B, 3C, 4D, 5E. It is used for local network communication, within the same LAN. Example: when data is sent from one computer to another on the same network, the MAC address is used to deliver the message. IP address, Internet Protocol address. An IP address is a logical address assigned to a device for identifying it on a network. It works at the network layer, layer 3, of the OSI model. There are 2 versions: IPv4, for example, 192.168.1.1, and IPv6, for example, FE801A, 2B, 3C, 4D. IP addresses can be dynamic, changes every time, or static, manually assigned and fixed. It is used to route data between different networks, e.g., from your home network to a website on the internet. When a laptop connects to a different network, the MAC address stays the same because it is built into the device's network interface card. However, the IPv4 and IPv6 addresses change because they are assigned by the network or Internet Service Provider, ISP. The MAC address is permanent, while IP addresses are dynamic and depend on the current network. Network addressing, displaying the addresses. To view a device's network addresses, such as the MAC address and IP address, we use the ipconfig command in the command prompt, Windows. To see detailed information, type ipconfig, all. This command will display the MAC address, also called physical address, the IPv4 and IPv6 addresses, the default gateway, subnet mask, and more. This is a helpful way to check network settings and troubleshoot connection issues. Network addressing, IPv4 address format. An IPv4 address has 2 parts. Network identifies the network where the device is located. Host identifies the specific device on that network. The subnet mask is used to determine which portion of the IP address belongs to the network and which part belongs to the host. Network addressing, IPv6 address format. An IPv6 address is a 128-bit address, written in hexadecimal and separated by colons. Example: 2001, 0DB8, 0000, 0000, 0000, FF00, 0042, 8329. IPv6 formatting rules. Omit leading zeros in each segment. 0 decibels 8 becomes dB8. Omit all consecutive 0 segments using double colons. Only once per address. 2001, 0DB8, 0000, FF0000, becomes right pointing arrow 2001 DB8 FF00428329. Network addressing, static addressing. In static addressing, network settings are manually configured and do not change automatically. To communicate with other networks and the internet, the following information must be provided. IP address, a unique address assigned to the device. Subnet mask, defines the network and host portions of the IP address. Default gateway, the router's IP address used to reach other networks. DNS server, translates domain names, like www.google.com, into IP addresses. Static addressing is often used in servers, printers, and devices where a fixed IP is important. Network addressing, dynamic addressing. In dynamic addressing, a device automatically receives its IP configuration from a DHCP, Dynamic Host Configuration Protocol, server. The DHCP server provides IP address, subnet mask, default gateway, DNS server. This method is commonly used in home and office networks because it's quick, easy to manage, and reduces manual errors. Network addressing, DNS records. When a computer or device wants to visit a website like xyz.com, it needs the IP address of that site. But humans remember domain names, like xyz.com, not IP addresses. That's where DNS, domain name system, comes in. If the IP address isn't already known, the device sends a DNS query to the DNS server configured in its IP settings. The DNS server may receive questions like, what is the IPv4 address of xyz.com domain name? What is the IPv6 address of xyz.com domain name? What is the IP address for emails forwarded to the @xy.com domain name? Do you have additional information about the @xy.com email domain? To answer these, the DNS server looks at its stored data called resource records, RRs. These records map domain names to IP addresses, and also provide other information about the domain like mail servers or security settings. Network addressing, DNS records. A DNS server stores domain name information in a special file called a DNS zone database. This database contains a list of resource records, which hold details like IP addresses and mail servers for each domain. When a device sends a DNS query, e.g., asking for the IP address of xyz.com, the DNS server checks its zone database for a matching resource record. If a match is found, the server replies with the correct information, such as the IP address. If no match is found, the DNS server forwards the query to a higher-level DNS server to get the answer. This process ensures that even if a local DNS server doesn't know the answer, it can still help find it by asking other DNS servers. Network addressing, DNS records, spam management. DNS services can be misused by cybercriminals, threat actors, to support spam email campaigns by spoofing or faking email sources. To prevent this misuse, DNS servers now use special, text, resource records to add anti-spam security features. These TXT records help email servers verify if a message really comes from the domain it claims. Some common uses of TXT records for spam protection include SPF, Sender Policy Framework, lists authorized email servers allowed to send emails on behalf of a domain. DKIM, Domain Keys Identified Mail, uses cryptographic signatures to verify that emails were not tampered with. DMARC, Domain-Based Message Authentication, Reporting and Conformance, builds on SPF and DKIM to provide instructions on how to handle emails that fail authentication. By using these TXT records, domains help reduce spam and phishing emails and protect their identity. Network Services, DHCP Operation. DHCP, Dynamic Host Configuration Protocol, allows devices on a network to automatically receive their IP address and other network settings without manual configuration. It works in a client-server model where the DHCP server holds a pool, scope, of IP addresses that it can assign. The DHCP client, like a computer or phone, sends a request to get an IP address when it wants to join the network. 4-step DHCP process. DHCP Discover, the client broadcasts a message to find any available DHCP server. DHCP Offer, the server replies with an available IP address and other settings. DHCP request. The client requests to lease the offered IP address. DHCP acknowledgement. The server confirms and leases the IP to the client. After this process, the client is configured and can communicate on the network. Next part will be continue in the next lecture. Thanks for watching. Subscribe our channel Network Professionals for more informative videos.